Hello everyone, I am your teaching assistant Balaji and I will be discussing the solution for assignment 1 here. So what we will do is we will go over one question at a time and discuss the solution for it. Any doubts regarding this material can be taken up in the forum. So please feel free to ask any questions you may have in the forum. So let's start off. A physical memory has a word width of 64 bits. This mandates the logical memory map to adopt a data bus of width 64 bits. So data bus width, let's take for example a 2 KB memory, and let's say that it has a data bus of width 64 bits with 32 words. So 32 into 64 will give you 2 KB, right? So now let's say the logical memory map for that is 8 bits, a bus width of 8 with 256 words. So 256 into 8 gives you 2 KB. So it is completely in the hands of the software programmer to decide the bus width and the number of words for a given memory. It does not have to do anything with the physical memory map, as long as this condition, that is the number of words into the bus width, is equal to the memory size, right? So it does not have to adopt the exact same bus width of 64 bits, and hence the answer is false. Let's go to question 2. After every instruction, EIP must be incremented by the programmer with a specific assembly instruction. So let's look at EIP. EIP gets auto-incremented by a certain amount based on the opcode size. The microprocessor calculates this value during the decode phase and auto-increments it. So the programmer per se does not have to manually do this. It is done automatically, and hence the answer is false. Okay, let's look at question 3. A stack is a last in first out kind of memory. So this is true. Okay, let's look at how this is true. So what happens in a stack is, let's say we do push AX. So what happens? AX gets pushed onto the stack AX, and the stack pointer ESP goes up and it becomes ESP plus 4, right? So now let's say you do push BX. So BX goes and sits here on top of this, and again forcing the stack pointer ESP to ESP plus 8, right? Now let's say we execute pop CX. What happens now is this element which is on top of the stack gets transferred into CX. So CX will have this element. So hence the element which is right on top is popped out. That's why last element which was pushed into the stack gets popped out first. So that's why the name last in first out, and hence this is true. Okay, let's go to question so let's go to question 4. Segment registers are used to demarcate different types of memory segments, such as the code, data, stack, and extra segment. So this is true, as we know that the segment registers are CS, DS, SS, and ES. They are used to demarcate the memory into 4 segments, and each of these segments have certain other registers like EIP, EAX, etc. associated with them. We'll come to this in the next question. So question 5, when referring to value in EIP, so the data is accessed from the stack segment. Okay, so EIP is a register which is associated with the code segment register, segment register ECS. So hence the value in EIP refers to some memory location in the code segment, and hence this is false. Question 6. Flag register is altered when logical comparison operations are performed. Yes, so this is true because the flag register is basically changed by any type of logical operations, like let's say you do CMP AX comma 0. So what happens if this is 0, the 0 flag is set. If not, the 0 flag is remains in its default value, which is 0. So yeah, hence this is true. Okay, so question 7. The instruction move AX comma BX copies the value inside the register BX into AX and clears the contents present in BX. So this is false. So what happens? Let's say you do move AX comma BX. The AX register now is having the value of BX, but the value in BX remains there as it is. So that is why this is false. The instruction move AX comma 43 is immediate mode of register addressing. So yes, this is by definition true. So the immediate mode is wherein a register move registered comma data. So this is the format for immediate addressing mode, right? So let's look at question 9. The move SW instruction does not affect any bit in the flag register. So this is a data movement type of instruction, hence the flag register is not affected. So what happens is there is some kind of data movement associated with this instruction. So the flag register is not affected at all during this process. Okay, so this takes us to section 2, where we will be answering the problem solving type questions, right? So question 10. The value stored in the register AX comma BX after the execution of the following code snippet is. So what happens, and we will look at what happens in each line. So this line AX is equal to 10 happens here, BX is equal to 2 happens here, mul BX. So what happens here is AX is equal to AX into BX, which is 10 into 2, that is 20, right? Then yeah, as we saw earlier in another true or false type question, the value BX remains unaltered, hence AX is equal to 20 and BX is equal to 2 is the right answer, right? Question 11. The value stored in the register AX comma BX after the execution of the following code snippet is. So as we saw earlier, the CMP, the compare instruction, only alters the flag register. Sorry. So it alters the flag register and does not affect any other register. Hence the value of AX and BX remain the same. So this is the correct answer. AX equal to 10 and BX equal to 2. Question 12. If AL equal to 17H, CL equal to 34H, okay. Analyze the following assembly code snippet. What is the value of SP after the following code executes? So let's go from here. So push AL pushes AL into the stack, wherein let's look at what is happening here. So AL goes into the stack here, push CL. Now again, once it goes into the stack pointer is incremented by 2 because it is AL. Now push CL, again CL goes and sits over here, and the stack pointer is incremented by 2, so SP is equal to SP plus 4. So pop word pointer of ECX. So what happens here, since it's a word pointer, the value see, this whole thing gets popped out, right? After this, the SP, the stack segment pointer, the stack pointer, again comes back to SP. So it decrements by 4 and comes back to this exact same location, which is SP. So initially SP was FF45, and finally after the execution of these three instructions, it is again FF45. Yeah. So let's look at question 13. The value stored in the CX register after the above code snippet executes. So let's look at this set of instructions one at a time. So STD sets DI to 1. Move AL comma 10. AL is equal to 10 and CX is equal to 3, DI equal to 0237H. Repne's CASP. Since DI, the direction flag is set to 1, now it will auto decrement and search for this variable 10 in the memory location until CX, which is the count variable, goes to 0. If it goes to 0, it continues with the next instruction. If it does not go to 0 and if it finds this value 10 in one of the memory locations, it stops there. So let's look at what is happening here. So the first value for the first data element is 25 here, and as we can see, because DI is 0237, ES colon DI is 31237H, which is this. Okay, so now we start comparing AL with each of these data elements. So 10 comma 25, which is not true. So 10 comma 15, again not true. So 10 comma 10, we have gotten the result. So here CX was 3 initially, it decrements to 2 and then to 1. So after the execution of this last line, the value of CX is 1. That is clearly evident here, and that is the answer, CX equal to 1. Okay, now let's go to question 14. The value stored in the register DI after the above code snippet executes is, so what happens is the DI auto decrements and it goes to 31236, this, and then 235. So this is ES colon DI. When you look at what only DI is, it is 0235H. So hence the answer 0235H. The 15th question, the value of the direction flag after the above code snippet executes. So in the very first line, we have seen that STD is executed. So the direction flag is equal to 1. Sorry, I had mentioned DI here, it is DF. Direction flag is equal to 1. The instruction Repne's CASP, as shown above, causes a software loop wherein the instruction translates into several lines of machine code. That is wrong. It is not a software loop, it is a hardware loop, wherein the instruction finishes in one shot and only then moves on to the next instruction. So all of this CX becoming 2 and 1 and DI auto decrementing, all of that happens over here, which is in this instruction line. So it is a hardware loop wherein the instruction finishes in one shot. This is the key point. Look at what this is. A one-time comparison between the register AL and the data at the location pointed to by DI. So this is not a one-time comparison. It compares until the two criterions, which is CX going to 0, or if there is a match that is found. These are the two criterions. An infinite loop that checks the entire memory for a match with AL. So this is also false. It's not an infinite loop. Question 17. In case a match is not found until CX equal to 0 in the above code snippet, then it causes the program to stop and resets the IP to the start of the program. No, this does not happen. Inverts the direction flag and causes the program to restart. No, this does not happen. Gets stuck in an infinite loop. No. Proceeds with the next instruction to be executed. So it just proceeds. So it proceeds in exactly these two cases, wherein either Cx goes to 0 and does not find a match, or if it finds a match, it stops there and goes to the next instruction. So before we go ahead to question 18, we'll just go back to this. I'm sorry about this. This is a mistake. This is supposed to be ES colon EDI, and this is supposed to be EDS colon ESI. So please make note of this change. Okay, so let's now jump to question 18. What is the data stored in the address? This, okay, respectively after the execution of above snippet until label 1. Okay, so let's go over this one instruction at a time. So std sets the direction flag to 1. Move si, so this is equal to 0237. di equal to 0237. ecx is equal to 2. rep equal to cmpsp. Okay, so now we compare. So what is si here? It is basically es colon di and ds colon si. So es is 3100 and si is given as 0237. So it is this es colon di and es colon ds colon si. So this is the initial address at which si and di are pointing to. So rep equal to cmpsp. So since the direction flag is 1, the addresses are in cmpsp forces the addresses to auto decrement, right? Okay, so initially 25 and 25 is compared, it is equal, and hence it moves on to the next address location, which is 82236 and 31236. So it now finds that 5 and 15 are not the same, so it stops and label 1, the execution of this statement is done, right? So let's look at what is being asked. What is the data stored in these locations? Okay, since this is just a comparison operation, there is no change in data, hence you can see the data is 1538, 5 and 38. 1538, 5 and 38, right? Okay, let's go to question 19. Before that, we will just make note of what is the current value of si di. So si currently is equal to 0236h, di is equal to 0236h. ecx, since it's auto decremented by 1 and it finishes there, ecx is equal to 1. So this is the current set of values. Okay, so now let's go to question 19. What is the data stored in these addresses respectively after the execution of above snippet until label 2? Okay, what is label 2 doing here? Rep move sb. So move sb moves the data from the source index to the destination index. So here we are starting, the source is here, the source index is here, the destination index is here. So the data is 515. So since there is no condition, it happens until ecx goes to 0. So 5 is being transferred here, so this becomes 5. Then 2 is being transferred here because ecx equal to 1 here, ecx equal to 0 here. 2 is being transferred here and this becomes 2. So this becomes 2. What is the data stored? Okay, fine. What are they asking for? So they're asking for this date, this, 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 and this. So it is 538, 5 and 38. As you can see, it is 5, 38, 5 and 38. Okay. The value in the register ECX after the execution of above code snippet until label 1. So until label 1 we have seen that ECX is equal to 1, right? And after label 2 completes its execution, ECX goes to 0. So 1 comma 0 is the right answer. Yeah. Okay. So now let's move on to question number 21. The assembly code is intended to perform which of the following operations? Okay, let's look at this code first, what it's doing. So EAX is equal to 1, ECX is equal to value in the address this, but by default, since it is in the data segment, so by default you'd say DS colon 0235. So this is A2 this and A2235, right? Okay. So the value in this address is 4. Now this is put into ECX 4 mul ECX. Okay, so what happens here is EAX equal to EAX into ECX. So here it is 1 into 4. Decrement ECX. ECX becomes 3. Compare if ECX is 1. If equal, if not equal, go to this label. Okay, so it is not equal, so we go back to this label again. What happens is again now it is 1 into 4 into 3. Now again ECX is decremented and it is checked for this condition. It's not equal, so we go back and do 1 into 4 into 3 into 2. Now ECX is decremented, so now it is equal, so it does not go back. So how many times? Okay, fine, let's look at the question. What is this doing? Basically it is 4 into 3 into 2, which is nothing but a factorial of the number present in this address location, right? So this is the right answer, others are wrong. Okay, so question 22. How many times does the instruction the label repeat AG get executed in the above assembly code? So initially first time it comes here once, then second time when ECX is 2, you go back here, which is the second time. Third time when ECX is no, the first time when ECX is equal to 4, you come here. When ECX is 3, you go back. When it is 2, again you go back. When it is 1, you do not go back. So in total we have 3 times, right? So 3 is the right answer. What is the value of the register EAX after the above assembly code executes? EAX, as we can see, it is 4 into 3 into 2, which is 12 into 2, which is 24, right? EAX equal to this, so which is 24, and this is the right answer, 24, right? Okay, so yeah, we have come to the end of this discussion. If you have any questions regarding this discussion, please make sure you ask them in the forum. Thank you very much.